Okay, so I would like to give you an overview on Chef, and Chef is actually coming in when you have this kind of problem. So when you need to build your server, you need to compile stuff, you need to download stuff, and probably you want then to have the same infrastructure on your live system somewhere in your EC2 cloud or whatever. So Chef helps you with this. Namely, it can make your infrastructure programmable, it can make your server repeatable, and the key to this are the abstractions in Chef. And it reminds me a little bit on the MVC pattern, because in Chef you also have like attributes for the server. You have controllers which are actually doing the works. And the config files are living in templates, which are very important too. And basically you can practice this kind of server building with Vagrant, and it's a little bit like a laboratory, I would say. And you run often Vagrant provision, and you get a new server. So there are many tools around Chef, and one of the tools I like right now most is the workshelf thing. It's like a bundler, so you just say, okay, I want to have RabbitMQ, I want to have Erlang, I want to have Postgres or whatever, and Workshop will download the cookbooks, and afterwards you can build then the server with it. So I wanted to show you an example maybe for Ruby 2.0 and Rails 4 stack. You normally would look at the application cookbook, but you can do it yourself too. This would be the cookbooks you need for a complete web application stack. Then you would download this with Works install and and you would then prepare your virtual machine with the Vagrant file. You can actually load this stuff from your Node.json, which is some kind of wrapper for your setup for the virtual machine, and you run this. This is some details about RVM, and if you're lucky, and maybe you need to run it 2 or 3 times, because there are dependencies within the runs sometimes, and you will then have a Ruby 2.0 and Rails 4 gem installed. So some conclusions here and some links here. So even it was too fast, so you catch that now.
I mean, those are lightning talks, but it was faster than lightning.
Yeah.
Are you ready?
Yes.
Are you sure?
Bash! Bash is a problem, I tell you. It is really slow, and that bugs me like hell. It is super annoying, I hate it. I want to be fast. I want to have my tools be responsive. It's hacky. Have you ever looked at the Git completions file and understood a single line of code there? This thing is crap. It's totally hacked together with, I don't know, it's very inconsistent. I don't like it therefore. And it's dated. I mean, it's technology from the 70s. Okay, enough of the bash bashing. I mean, it serves us all, so. Let's see the solution, or what I had. Today I was fed up. I mean, this morning I was sitting here and doing something with my bash shell, and I was so fed up that I talked and say, hey, I want to find a new modern shell. So I went to Google and typed in modern shell, and this is what came up. So I'm just telling you a little bit about fish, what it does, and why it's performant, and why it's probably cool to have a look into it. And of course, like Lightning talks about selling stuff, so yeah, it's incredibly fast. It uses threads, so imagine Bash is forking a lot and using subcommands a lot. and also accessing the file system in subcommands. It's all blocking. And Fish is using threads to speed up those processes. It's really fast on HDDs, therefore. And think SSDs. It already knows what you want to type before you hit it in. And it's modern. It's like a quite recent implementation, and this is a shell of the 90s. And I'm a kid of the 80s. I used to listen to techno music, fast music, drum, bass, and everything. So I want to have things responsive. So I quite fond of this setting to modern it. Yeah. And it has real VGA colors, native support for term 256. It's web configurable. I will show you later. It's unobtrusive. So it tries to get out of your way. Auto suggestions are based on your history, not on some auto-completion file. Auto-completions for commands and flags for commands are based on man pages for those commands. And helps also your fingertips. So it's using the man page system to also show help to the flags and show help to the commands you're using. I show you. You know, live demo some such. Here's a new fish shell. It's super fast. Let's type something in, hit tab. You see all the commands from Git, and you see, for example, the help with those commands. Very nice. You can tab and see, oh, what commands do I have here for ls, for example, and look into it. Really nice. I won't show you more because I'm quite running out of time. So here's how you install it. You do brew, install, fish, echo use a local bin fish into the etc. shells. This is Mac OS 10 specific, so I'm sorry, I have no code about Linux and everything else. So, and then you change shell to fish. Read about it here. This is the URL. And the whole thing is about like modernize your tools. The tools you use every single day. Don't spend too much time waiting for a shell to come up. Try to find new ways and modernize your systems. Thank you.
I guess it's so fast because it's written in a functional language, isn't it?
Okay. So where's the mic?
Here's the mic. Ready, set, go.
Okay, so hi everyone. So at Base, every once in a while we do Hack Your Case, which are basically an opportunity for us to get together with other hackers, drink some beer and code, because it's all about code. The last time we did this, we were coding games in Ruby. They were like old vintage games, usually ASCII art, so I'd like to share with you kind of a short video of what went on the last time we did this. Oh yeah. Yeah, so it was a ton of fun, and during those, it was actually under 5 hours, and 16 games were created back then. And so it was a ton of fun, and we decided that it would be cool to share and do something like this in other cities as well. So right now we're working with folks from Hackathon to create a similar event here in Wrocław in just a couple of weeks. We don't have the date yet, but we will know that soon. And so I'd like to invite you all here. It will be a full-day hackathon, one Saturday probably in 2 or 3 weeks. And there will be food, drinks, prizes. So I'd like to invite you there. If you'd like to learn more about it, be notified when it is, and also get free tickets because it's going to be a paid event. But today we'll be giving away free tickets. Then come talk to me or just go to bit.ly/hackbro. So. Yeah. So under that link, if you fill out the form, we'll let you know what it is, and we'll also give you a free ticket. So basically, that's it. Thank you.
Hi, so I'm Tim from Berlin, and I want to talk about the most valuable material in the world today. And so you wonder, what is this fantastic stuff? Is it gold? Or is it diamonds? Or is it something even more exotic, like stem cells, special stuff? No, it's something else. It is unobtainium. So where is this unobtainium? Where can I get it? Actually, a pretty big reserve of unobtainium is in this room right now, because unobtainium is developers. I think developers are the most valuable resource in the whole earth, because right now no company can be successful without good developers. So it's pretty cool, right? That we are actually developers. But there's one thing that bothers me. And it's searching for a new job. It's like, if we are so valuable and so important, why is job search so difficult and such a painful process? So, I want to change that. What I want to do is reverse job search. So the idea is, basically, if I want to find a new job, I don't want to go hunting for the job, I want the job to find me. So the idea is that I describe what my dream job would look like, and then sort of like put this out there, but put it out there anonymous, right? So then people can, the job can find me. That's the idea. And I built a little website to validate this idea, and I would invite you to check it out. Right now there is exactly one profile in the database, that's me. And I would hope that at the end of the weekend there are quite a few more, hopefully. And that's it. If you have any other questions or suggestions, please just get in touch.
You're killing other recruiters.
There we go. I'm going to talk a bit about the numbers, or more precisely, the magic of the number 12 when it comes to scaling distributed systems. Basically, what the number 12 is that it's the best number for distributing stuff, because it's you can divide it by 2, by 3, by 4, by 6, and if you go a little further than 12, You can divide it by 8, or you can divide it by 5. And this nicely enables you to build very highly composites, such as if you look at 12, 60, 120, or 360, you can divide by 2, 3, 4, 5, 6, 7, 8, and so on. So that's basically the biggest lesson that we learned. If you want to build this distributed system, pick a multiple of 12, like if you have queues into your application, or if you want to, say, pick the number of nodes on a Cassandra wheel, for example. And also, how's the time? Oh, we can also check quickly something more about numbers. Like the reason why there's 60 seconds to a minute and 360 seconds to 360 degrees to a circle. You have 3 segments on each finger, which means that if you count each segment, that's 12. And if you count each finger, that's 60. So that's pretty cool. Another fun thing that you can do with, if you look at number 36, which is a dog. If you take a number and you represent it by base 36, you get 31 bits, which is pretty much close to 4 bytes. And you can represent timestamps as 6 bytes. This way. So that's pretty clever, because that's a very nice compact way of representing time if you want to send it, for example, over HTTP, which is what we do in a lot of our IDs and stuff. What am I going to talk about then? No, I think I'm done there.
Okay, so we're halfway through.
Yep. Okay. So my name is Brian Helkiam. Uh-oh, and I lost my video. Okay. So this is going to be a very small version of the talk that I was planning on giving. I make Code Climate. Code Climate is a tool that analyzes your Ruby applications by connecting to your Git repository and doing a bunch of static analysis. And I'd like to show you something new that we've cooked up. Just for people who might not be familiar with the website, this is an example of a project on Code Climate. You can see a little bit of an activity feed. And let's see, hold on. Okay, now I can scroll. We'll also grade each class from A to F based on the smells that we identify in the class, and show you things like where the hotspots are in your application. For every class, you get a page like this that gives you specific information about what's in it. In this case, the user class has a really complicated actionize method. We can also identify things like duplication. So this login controller has repeated structures for the respond to blocks. And then we track that over time. So you don't have to do anything, you just get this information regularly updated, emailed out to you for important stuff. But the new thing that we're launching, which I want to talk to you about, is what we call Security Monitor. So Security Monitor expands Code Climate from doing quality analysis into doing detection of potential security vulnerabilities in your application code base. We've got some great open source technology we use under the code called Breakman to enable this. But basically, it's the same sort of model. We run around your code base, and we look for vulnerabilities of all these potential types. So you can see for each potential type of issue, whether Code Climate was able to find any cases in your code base where it thinks that there might be an issue. And then if there are, we'll tell you how confident we are that there's actually a real issue. So as an example, this is from Trax, which is an open source application, which, given this report, I would not install on your servers right now. This is a case of taking information from parameters and passing it to YAML load, which a lot of people in the Rails world realized recently was quite unsafe. So it can tell you if you're doing something like that in your code base. And things like unprotected redirects, everything can be marked as false positives to get it out of the way if you review it and you say, you know what, this isn't an issue. So your team can sort of work off just a set of things that need to be either reviewed and cleared or fixed. And because of that, we're able to do something pretty cool where if a new vulnerability gets pushed into your code base, we can send an email to your team letting them know that there's something that they need to take a look at. Ideally, this is something that a team can respond to before the code is actually making its way to production, because everyone's kind of pushing code more frequently, deploying on tighter cycles. We're trying to help people deal with, how do you do things like security review with respect to that. So it's not a silver bullet, but it's something that we think is, can be quite helpful to different teams. That's all I've got.
Okay, so let's start. So if you'd like to take part in Hackathon, you must write code very fast if you want to win. And I would like to talk the variable names. This is a very controversial topic, and I have somehow a different view on this. Although I do differently in my daily job, I have to conform to standards. I believe that the most readable variable names are short names, like 3-4 letters. And I have some justification which I would like to share with you. And I also noticed that C programmers use very short variable names. And as a good example of this, I recommend you to see the code of SQLite 3. The code is very well documented and very nice, but the variables are shorter, although function names are clear. So I would paint you my explanation. If you read a book, you don't read actually words, you only read complicated words. So you read actually outline of a word. So if you have R, this is some kind of glyph to you. You don't read it, you just keep it, you assume that it's R. And I would like to show you how this happens. So this might be justification for my hypothesis. When you look at things, you don't see things. I does not see things as they are. At the bottom of an eye, the let's say pixels are not located evenly. They are not like in camera. They're located very densely here and very sparsely here. So the actual picture is very blurry here, and details are in the middle. Also, when you look at things, eyes switch 3 times per second, more or less. So it creates some picture of what you are seeing. And this is then passed to the brain. Actually there are 2 parts of brain which are well examined. One is V1 stage, and the second is V2. And V2 section has a very interesting characteristic, because its characteristic is identical to Gabor filters. And Gabor filters are very hard to compute on PC. They require parallelism to be efficient. And what they do, they look those filters, extract the lines from the picture, and those filters can extract lines at any edge. You can generate those filters in Matter, for example. And so this is my justification. That's because the processing of small variables is faster by brain, and this way you can win Hackathon. Thank you.
Very interesting theory.
One, two. Are you ready? Yeah, let's start. Okay, I'm gonna do some tips about object-oriented design in your apps in 5 minutes, so that's gonna be tough. That will be 7 tips, in fact. Let's start with extracting application infrastructure logic out of controllers. What I like to do is I like to create tree structures of objects that contain this infrastructure application logic and move it out of controllers. So that increases code reuse. I could reuse that in different controllers, for example, API controllers, or in some other interface like command line interface or rake task or whatever to the application without changing the application logic, because it shouldn't change from view to view. What I like to do is to have these sections. For example, if I'm building intranet, I have a section that manages files, documents, etc., etc., and I can have that within this tree structure. What I can do at the same time is to ensure some visibility and security of the application. So, for example, for different users of the intranet, they're getting a bit different application. The managers can get like full-featured intranet application that they can create, delete, remove files, etc. But normal users, normal employees will only get read-only access. And there's no way they actually can break that, because the application they're getting doesn't implement removing documents. You can see, for example, here, that if actually in the base class it could be a method missing implemented, that if method has been called that is not implemented in this base class, but it is implemented in the parent ancestor class, then we throw some error, and we can obviously catch this error and log it and display error page for the user. The other fine thing which I like to use, especially when I'm not using active record, is to use repositories. This is a design pattern that allows you access and query database. This is a very simple implementation of repositories, base class. I actually use that in one of my projects. I can inherit from this repository, implement specific methods that I need, and I'm actually getting something that behaves like enumerable. I can iterate over it. There's one method which is like 3 lines to add pagination to it. And you actually can use it in combination with the other parts of architecture, so different users can get different repositories. This is done with the query object, so this is something like, this is another pattern that can be used in conjunction. Basically, you can replace behavior and show only those records that user has access to by changing the query object. What I like to do is to have this lambda here, but it doesn't have to be. It can be a method, it can be a class or whatever. And when doing the same, I also like to have this parallel test that, I do domain-driven, I design test-driven, behavior-driven development. I write tests for my application interface, but I also write tests for my internal application interface, which is the structure we just created. This is another fine thing, which is dependency injection, but let's skip that. The last thing is testing. It's related to testing. So when you test a class, you don't necessarily have to stub out some methods out of it. For example, this is like a classic example. When you have API client, the least code substitution principle says that you can reuse in a test subclass of the class, so you can inherit from it, replace the method that is problematic, for example, calling external API with something that's not calling external API, and write our tests as they will be running against the base class, and that should be fine, unless you do something really wrong. Okay, I think I'm done. Thanks, guys.
Was it really 1,000 words? Was it really 1,000 words?
No, that was it. I changed the name.
Really?
Okay.
So this is a short version of the talk that I did last month in Berlin You can, I don't have slides with me today, but you can find the full slides if you Google for YAML is the new eval. So this is a talk about security, and mainly what I want to say today is that security is an emergent property. What that means is an emergent property is a property that a system has, that it exhibits, and that is not in just one of the parts, but it's, you have a lot of simple components interacting, and through their interactions, the whole system starts to exhibit a certain feature. It's important to think about security that way, that it's not just a feature. You know, you can have specific security features like CSRF in Rails, you know, and Rails claims to be secure by default, but it's still really easy to shoot yourself in the foot. And security researchers actually most of the time assume that if a system is complex enough, that it probably has infinite vulnerabilities, that most of them just haven't been found yet. And the reason is that a vulnerability is always like an interplay between different things. You know, you see that with the recent vulnerabilities, like, okay, you know, YAML does object instantiation, but because we're parsing YAML from our input, and because named route helper, you know, allows that to be used for remote code execution, like all these things come together. And so it's that way with vulnerabilities, and it's also that way with security as a whole. Like, you making your app secure is not like gem security in your gem file, bundle install, and you're done. Couple things about that, like keep your objects basically ignorant. This is a rule that you can't break what you can't touch. So make sure that every part of your system only really deals with the stuff that it needs to deal with. And of course, sanitize your inputs. So it's a very Railsy thing to just put something from params straight to active record create. I think that's a big anti-pattern. Basically, you know, Rails gives you really fancy input handling, parameters handling. You can do, you know, XML, JSON, but that means that anything that is in params can be nested hashes, nested arrays, you know, can be integers, strings, true, false. It could be symbols, I think not anymore. So yeah, basically, before you do anything with params, with cookies, with something that comes from your request, convert it to what you think it should be, or check that it is the type that you think it should be. There's a gem called save parameters that can help with this. So yeah, don't just assume that because Rails is default safe that you're safe. Like, be smart. Well, I still have a minute. Okay, for your rejects, don't use dollar and carrots to anchor them to the beginning and the end, because that only works with beginning and end of line. So a hacker just puts a new line and puts something else there, and your rejects passes and you're good. So use /A, /Z. Check out Brakeman, the code farm guy already mentioned it. It does static analysis of your code. It's pretty cool. Yeah, and for more stuff, yeah, just Google YAML is the new eval. I'm Plexus on Twitter. Thank you, guys.
Okay, one more to go. Okay. Hello? Hello? It's unfair to run the time. Yeah. Hello?
Hello? Okay, so it's not a programming talk, it's technology talk. Bitcoin. What is Bitcoin?
A super cool currency. Peer-to-peer. Woo!
It's a currency, right. It's an open source currency. It's a peer-to-peer currency. Basically, you have your money in a file on your own computer, and you can send it to China in a matter of minutes for free. It is the first time in history that someone managed to solve so-called double spending problem. I mean, you can copy your file, but it doesn't mean you have twice as much money. You can spend this money only once, and it is the peer-to-peer network that guarantees that. Bitcoin is based on cryptography. Basically, that means that your money is your private keys, and you can send your money to someone else's public key, and then he uses his private key to send this money further. The big advantage of Bitcoin is that you can earn Bitcoins anonymously and then spend them anonymously. Bitcoin brings back privacy to your personal finance. Does it resonate with you?
Yeah.
So the network is in operation reliably for 4 years now. So I think we can rely on that. You can buy Bitcoins for Polish zlotys or for dollars or for many other currencies on Bitcoin online exchanges. The price continues to grow. So what can I say? If you like big government, then do not get interested in Bitcoin. If you like top-down managed economy, do not get interested in Bitcoin. And if you love paying taxes, then definitely do not get interested in Bitcoin. Thank you.